more than 30 times farther from the Sun, almost at the edge of our solar system. There's one mysterious planet, Neptune. It's impossible to see it, even from the highest points on Earth without a telescope. Because of its remoteness, Neptune is the least explored planet in our entire system. But what could be so mysterious about this planet? Would you be surprised if we told you that Neptune, one of the coldest planets in the system, can support an ocean of super hot water? Today you'll learn about that, as well as Neptune's strange rings, what makes it so blue, and also what is now known about its famous satellite, Triton. Neptune is an ice giant, about 4 times wider than Earth. It has a radius of about 15,300 miles and a volume of 15 trillion miles cubed, which means that Neptune is 58 times larger than Earth in volume. The planet is composed mostly of water, methane, and ammonia. Like the other ice and gas giants in our system, Neptune has no solid surface. Its atmosphere extends deep into the planet to the mantle, which is composed of methane and ammonia ice and a rocky core. Nevertheless, scientists believe that the ice giant could theoretically have an internal hot ocean. But how can a planet sustain such an ocean since it's so far from the Sun? It would take sunlight 4 hours to reach the giant's surface. Neptune's average atmospheric temperature is negative 360 degrees Fahrenheit, making it one of the coldest objects in the solar system. In addition, according to recent research, most of Neptune cooled from 2003 to 2018, despite warming near the South Pole from 2018 to 2020. Likely due to seasonal changes in atmospheric chemistry. The reason for the likely formation of the ocean inside the ice giant remains unsolved. However, scientists suggest that this strangeness can be explained by internal heating. Heat released due to gravitational compression or gravitational interaction between Neptune and one of its satellites, Triton. On the other hand, researchers Sloan Viktorovich and Andrew Ingersoll believe that the probability of oceans on Neptune due to its heat is very low, only 15% at this time. According to scientists' calculation, only in 1 billion years will the chance of an ocean there increase to 40% after the giant cools down. Another explanation for the huge internal energy could be Neptune's collision with some cosmic object, because Neptune is the only planet that emits nearly 3 times as much energy as it receives from the Sun. This is also confirmed by the unusual 28-degree tilt axis, almost as much as on Earth. Because of this, Neptune also experiences seasons similar to ours, but on Neptune, one season lasts about 40 years. 1 year for Neptune is 165 Earth years. Yet 1 day on the ice giant takes 16 hours. This rapid rotation of the planet creates super powerful wind, which we'll talk about a little later. Neptune's atmosphere is 80% hydrogen. It also contains 19% helium and about 1% of other gases, including methane. By the way, Neptune's blue color is caused precisely by methane clouds in the upper layers of the atmosphere. Methane molecules can absorb solar shortwave radiation, reflecting the blue color. However, the nearest planet to Neptune, Uranus, also contains a similar distribution of gases. But unlike Neptune, the color is pale blue. Dr. Patrick Irwin of Oxford University suggests that this color difference may be due to the density of methane fog. Thus, the atmospheres of both planets have several aerosol layers. The bottom deep layer consists of a mixture of hydrogen sulfide ice. It's because of this layer that some areas can be seen closer to the poles. For example, they appear darker on Neptune. The second layer is probably just what affects the colors of the planets. It's a layer of haze particles in which methane ice probably forms. The ice then precipitates as a rain of methane snow. Since Neptune's atmosphere is much more active than that of Uranus, Neptune forms this snow more efficiently. So its second aerosol layer is thinner. It is precisely the lower density that causes this rich blue color. The last third atmospheric layer also forms large particles of methane ice and is, in fact, an extension of the second layer. In addition to its intense color, Neptune is also characterized by dark and white patches all over its surface. All of these spots are storms resulting from the planet's very rapid axial rotation. Neptune is the windiest planet in the system. Wind currents there can reach 1,200 miles per hour, which is almost 4 times stronger than Jupiter. However, the ice giant has one similarity with Jupiter, a huge storm. The name of this vortex is simple enough: the Big Dark Spot. The Earth-sized cyclone orbiting at 1,500 miles per hour was first detected by the Voyager 2 spacecraft in 1989. However, in 1994, another telescope, the Hubble, noticed the spot had disappeared and a small new spot appeared in the northern hemisphere. So unlike the 300-year-old cyclone on Jupiter, Neptune's large-scale vortices only exist for 2 to 6 years. In 2018, Hubble detected another new spot similar to the one discovered in 1989. The formation of these storms is still unknown, but scientists suggest they originate deep in the atmosphere, forming over several years. These storms still have something to show scientists. The new 2018 spot began drifting southward the following year, where it would have disappeared. However, unexpectedly for researchers, the storm turned around and began moving back north. What's more, a small one probably separated from the big spot. NASA scientists believe the small vortex may be part of the process of breaking up the big storm, which has never been observed before. Such cyclones in previous observations have been accompanied by white methane clouds called scooter because of the speed of motion greater than that of the big spot. They probably form over vortices, where gases freeze into ice crystals. The lack of clouds, the researchers say, may help in understanding the formation of patches on Neptune and similar ice giants. Like other gas giants, Neptune has another feature: a ring system. In 2022, the James Webb Space Telescope took a near-infrared image of the icy giant, showing its faint rings and satellites. The last image of Neptune's rings was taken more than 30 years ago by Voyager 2. In Webb's new photo, about 5 rings can be seen. All rings are named after astronomers who have contributed to the study of Neptune. The closest and most loose ring is called Halley. It consists of about 40% to 70% dust and is 26,000 miles and has a radial width of 1,240 miles. The second ring of Leverrier is much brighter, but much narrower. Its width is a little over 62 miles. The next ring is the widest of all. This is the Lassell ring, 2,485 miles wide. The percentage of dust there is very small, ranging from 20% to 40%. The fourth, Arago ring, is hard to see. It is one of the smallest rings with a radius of 35,540 miles. And it's on the edge of the Lassell, and probably because of its low dust content, is hardly noticeable. The last, Adams ring, has an orbital radius of approximately 39,724 miles. Moreover, Adams is only 35 kilometers wide, making it the narrowest ring of Neptune. But what makes this ring stand out in its arcs? The arcs are mysterious bright seals of dust around the perimeter of the ring. Each of Adam's arcs has a name: freedom, brotherhood, courage and equality. Interestingly, they are not static at all, these arcs. Especially brotherhood and equality exchange their material and change their size. Why these arcs formed is still unknown, but researcher Imke de Pater suggests that the cause may be the collapse of a parent companion or other object in the Roche limit. In addition to the rings, Webb also recorded 7 of Neptune's 14 satellites. All of the ice giant's moons are divided into regular and irregular. Webb captured 6 ordinary inner satellites. Some of these satellites, like Despina and Galatea, form Neptune's rings, playing the role of shepherd for dust. However, definitely the most interesting thing in Webb's image is the most distant bright satellite, Triton. In the photo, Triton looks like a star because it glows much more than Neptune. The strange glow is because the satellite is almost completely covered by nitrogen ice and therefore reflects about 70% of all sunlight that falls on its surface. Triton is Neptune's largest satellite. It is larger even than Pluto. It has a diameter of 1,680 miles, which can be equated to 99.7% of the mass of all Neptune's moons. It is also the coldest geologically active object in the entire solar system. Its surface temperature reaches negative 391 degrees Fahrenheit just because of its light-reflecting icy surface. Like any of the moons of the ice giant, Triton experiences wave blocking, meaning that only one side of it is turned toward the planet. However, its retrograde orbit sets it apart from other satellites, which is unusual and unique to all other satellites in our system. That means that Triton has an inclined orbit, which causes it to move in the opposite direction to Neptune. Also, because of this orbit, its poles and equator alternately face the Sun. But what could have caused such an unusual orbital tilt? Most likely, Triton never formed with Neptune. Scientists believe that Triton originally evolved in the Kuiper Belt, but at some point it was able to be captured by an ice giant, and it's assumed that Triton could hypothetically move around another object. Therefore, the captured Triton slowed down, which prevented it from colliding with Neptune. Moving toward Neptune, the satellite could also destroy other moons. Neptune has very few satellites compared to, for example, Jupiter, around which there are almost 70 objects. There probably could have been more, and they would have been larger had not Triton been captured by the giant's gravitational pull. Triton's features don't end there. If you look closely at pictures taken back in 1989 by Voyager 2, you can discern the satellite's unusual mosaic surface, modeled with plumes. According to the analysis of the craters by scientists, their surface could be from 10 million to 100 million years old, and in some places, the smooth surface on the manifestation of cryovolcanism. Therefore, scientists believe that the Moon may have a subsurface ocean. The plumes also probably hint at this and also depict a depression similar to a lake basin. Despite its low temperature, Triton probably retains a lot of ammonia beneath its surface, which slows the freezing of the water. On the other hand, plumes may appear due to heating by sunlight, causing nitrogen to compress beneath Triton's icy surface until the nitrogen escapes. At this point, proving that the satellite could be an oceanic world is very difficult. In addition, solar heating probably forms the Moon's thin nitrogen atmosphere. However, the possibility of life developing there, as on presumably Enceladus, is too early to tell. Given that Triton was part of the Kuiper Belt, does this mean that Neptune can influence its objects? The Kuiper Belt is the boundary of our solar system, also the comet's source. The belt extends from Neptune 30 AU by about 20 AU. The belt is predominantly composed of small objects like asteroids and tens of thousands of more large objects, including dwarf planets like Pluto. Were it not for the gravitational influence of an ice giant, it's likely that a planet could have formed from the Kuiper belt. In addition, scientists have noticed that some objects in the belt, including Pluto, are in long-range resonance with Neptune. Usually such objects, planetesimals, can only temporarily come into resonance with a stable, fixed-in-one-place planet. Therefore, scientists suggest that it's likely that Neptune may have migrated from the inner regions of the solar system, meaning that it may have originally formed close to the Sun. Thus, the migration of the ice giant was probably able to keep many Kuiper belt objects within the solar system, when, without resonances, gravitational effects could have pushed them outside the system and even in our direction. Neptune definitely has many unexplored mysteries. At this point, we don't know, for example, the exact composition of Neptune's interior or in general how ice giants are formed. So we have to wait for future scientific expeditions that will help us better understand the chemistry of these worlds and unravel many of the mysteries that interest us.